Hi everyone! Welcome back to another video. Today I'll be discussing how geophysical hazard risks can be a product of economic, social, demographic, and political factors. So, a geophysical hazard is potentially damaging. It's a potentially damaging natural event or a phenomenon which may cause the loss of life or injury, property damage, social and economic disruption, or environmental degradation. So, a geophysical hazard originates from internal Earth processes. So examples are earthquakes, volcanic activity, and mass movement events, which are more, secondary. But it's still a risk. But mostly in this case, volcanic activity and earthquakes fit most well. Okay. Oh, and let's talk about economic, social, and demographic and political factors. So, economic factors. So, we'll explore about economic conditions such as poverty levels, infrastructure development, resource allocations, and how they can exacerbate or mitigate the impact of geophysical hazards. As for social factors, investigates the role of societal factors including community, resilience, access to information, cultural beliefs, social cohesion, in shaping vulnerability to geophysical hazards, and demographic factors. So consider how population density, urbanization trends, age distribution, migration patterns affect the exposure and vulnerability of communities to geophysical hazard events. And lastly, political factors. So here we will analyze the impact of governance structures, policies, regulatory frameworks, and decision-making processes on preparedness, response, and recovery efforts related to geophysical hazards. So I'll be using two examples for this discussion. So the first example is Haiti. So an earthquake that happened in 2010 Haiti. So let me just recap you on this. Okay. So in 2010, that's supposed to say 2010, Haiti earthquake, a large-scale earthquake that occurred in January 12, 2010, on the West Indian island of Hispaniola, compromising the countries of Haiti and the Dominican Republic. So most severely affected was Haiti, occupying the western third of the island. An exact death toll was proved elusive in the ensuing chaos. The Haitian government's official count was more than 300,000 heads, so which would make the earthquake's aftermath one of the worst natural disasters in recorded history. But other estimates were considerably smaller. And because of this earthquake, hundreds and thousands of people were displaced, like survivors were displaced. They were already living in informal settlements to begin with, but those informal settlements literally crashed down. So now, millions of people were left homeless. And if you're not aware, Haiti is going through a humanitarian crisis. There's a lot of corruption in the government. And on top of that, they experience cyclones and typhoons during the summer because of its, equator region. And on top of that, they get hit by an earthquake. So they get 3 hits. So you can't imagine just in what kind of state they might be in after this earthquake. It is absolutely heartbreaking. And more information on Haiti. So this is more geophysical. So there's a fault line under Haiti called the Enriquillo Plantain Garden Fault Zone. The Caribbean plate and the North American plate move laterally or side by side at a rate of about 1/4 of an inch a year. So the 2010 quake was centered about 30 miles west of Port-au-Prince. So again, to recap you on what a fault line is. A fault line is a long crack in the surface of the earth, and that's where earthquakes usually occur. So I hope that makes sense. It's just, a line on a rock surface or the ground that traces a geological fault where earthquakes happen. Simple as that. Okay, And you could look at this picture that I've put here. This is like an informal settlement where they had slums and a few houses. And you could tell that the infrastructure, how they made these houses, were not so sturdy to begin with. They did not have, insight into how to make houses earthquake proof and whatnot. They don't have the financial ability to make sturdy infrastructure. So this is what happens. Most people that got killed from the earthquake was not from the earthquake itself, but it was from, well, yes, it was from the earthquake, but it was from the buildings crashing down at them, and they get buried in there. Some people did not get found, and yeah. And the second example I have here is Japan, a country with very frequent earthquakes. And fun fact, actually, it is recorded that almost more than 1,000 earthquakes are recorded a year in Japan, like earthquakes. That is insane. So, the Japan earthquake and tsunami of 2011, severe natural disaster that occurred in northeastern Japan on March 11th, 2011. So it happened about noon, I think, like 2 to 3 p.m. So the event began with a powerful earthquake off the northeastern coast of Honshu, Japan's main island, which caused widespread damage on land and initiated a series of tsunami waves, large tsunami waves, like 40 meters, I'm talking 40 meters, that devastated many coastal areas of the country, most notably in the Tohoku region, hence, it's called the Tohoku earthquake region, and northeastern Honshu. The tsunami also instigated a major nuclear accident at a power station along the coast, which is another problem for another video. Yes, it's called the Tohoku earthquake, the Great Japan earthquake in Japanese. Yes, okay. And onto the geophysical information. So the Tohoku earthquake and the accompanying tsunami was the result of a major thrust faulting along or near the convergent plate boundary, where the Pacific plate dips to the west beneath Japan, the subduction zone being very active seismically. So remember, when we talk about convergent plates and divergent plates, we're talking about, plate boundaries. So again, to recap you, a convergent plate boundary is this occurs when plates move towards each other and collide. That's what it is. And diversion is the tectonics move apart. Simple as that. Okay, now let's look at economic factors. So, I have my notebook here with me, so I'm just going to read off of my notebook. Actually, my notes are actually really, really bad, so it may take a while. So, economic factors that we can discuss is, first of all, levels of income. The amount of wealth you have, the amount of monetary assets you have, really impact your geophysical hazard risk. The more income you have, the less risk you're in. But the less you have, the risk, the more risky it is. And hence, because you're so, if you're not financially stable, or you don't have enough financial assets to, protect your family, to get insurance, and all those things that are kind of like a social safety net, it really puts you in a vulnerable place, and it really increases that geophysical risk. So you could say that, these economic factors of, wealth distribution and wealth levels actually exacerbate your geophysical hazard risk, or it actually mitigates your geophysical hazard risk. So, and more on wealthier nations and stuff, like wealthier people and whatnot. So wealthier nations often have better infrastructure. We're all aware of that. They have building codes. So what a building code is, it's basically like, to build a house, you need this. You need to build your house on a concrete foundation. You need to have beams on your house. You have to have like 3 layers of concrete and whatnot. They will have building codes. But in countries that are not as wealthy and not as capable and really available to, look at these things because they're so busy with other things, they would miss that. And building codes are really important, especially in Japan. They have really, really strong building codes. It's actually one of the world's strictest building codes because of the 2011, 2011 earthquake they suffered from. There was relatively little damage because of the diligent enforcement of these building codes. The devastating effects were mostly from the tsunami with the Japan 2011 earthquake. And Haiti does not have any building codes, and they have a deficit of licensed engineers and architects. So they have people that are not certified, don't have degrees, actual degrees to work as a person in construction. That's why their houses can be unstable, and these kind of economic factors really, depend and go on many different spectrums. And if you're economically disadvantaged, like if you live in an economically disadvantaged area, you might lack resources for hazard preparedness. So this again also increases your vulnerability, which is the last thing you want when you face a geophysical hazard. Okay. I hope that's good. And just to, throw in another country, throw in another example, we have Alaska, which also has building codes designed to withstand the unique challenges of its climate. So, in their building code website on an official government document, they talk about how their building codes address issues like, the extreme cold, seismic activity, which is basically earthquakes, and snow loads. So they take these things into consideration because they have ample time. They have a regulatory framework, and they don't have a corrupt structure that prevents them from moving on to this. Okay. Yeah, I should have went on this slide. Well, anyways, let's talk about social factors. So the first social factor I wrote down was population density. But I guess that would be demographic as well. Well, a social factor can be like, let's just talk about population density. So when you say a population is dense, like there's a population's dense, you would say that that place is packed with people. It's packed, filled with people. So an example is, informal settlements like slums. There's so many people there. There's concentration of human beings door to door. And by having those, informal settlements, which is like in Port-au-Prince in Haiti has a lot of slums. Haiti is literally on a fault line. They literally have a fault line. And because there's so many concentrated neighborhoods of these, slums, it makes them super vulnerable, and the casualties are increasing as well. Because they're in such hazard-prone areas, the potential for casualties are very, very high. Yes, and moving on, let's talk about social cohesion. Social cohesion, community organization, and access to social services enhance resilience and adaptive capacity. So this shows how, global geophysical hazard risks can be mitigated. But things like population density, it can be a product, geophysical hazard risk can be a product of, yada, yada, yada. And another risk is, another factor from social is the lack of education, hence having low hazard perception. So they're not educated on this matter as much. They don't really know about earthquakes. And by not knowing this makes people think, yeah, I'm fine if an earthquake comes. Yeah, I haven't experienced it anyways. It's just a shake, right? What's so bad about it, right? They're not aware of that. And because of that, that increases their vulnerability again. And you could actually say that because of the lack of education that these people have, those cars are so loud. You could say that, it could be a product of a geophysical hazard risk. So, to put Japan as an example, earthquakes are really common there, right? As I said before, there's like over 1,000 earthquakes in like a year. More than. So, common occurrence. Therefore, they have heightened awareness. They understand what they need to do. Go under a table, for instance, or don't go near shelves. or evacuate the oh my goodness, building immediately, or grab emergency bags with you, wear helmets. They are aware of that. They received education in a way that instructs students like, hey, if you go through an earthquake, these are the procedures you have to take. You cannot panic. This is what you do. And they have enough technology. They have speakers around their neighborhoods that inform citizens minutes before an earthquake, like, hey, everyone, there's going to be an earthquake soon. You must evacuate. You must evacuate. And those iPhone, Apple, like, speakers, they would ring as well. I'm not sure if you've ever experienced that. But yeah. And, technology, again, they have access to social media. Everyone uses technology in Japan. So they know about the aftershocks, the news, and the state, social media, yada, yada, yada. All those goody stuff. Okay. Yeah. Oh, I made these slides for a reason, but yeah. Preparedness, social cohesion, access to social services. Yeah, but the lack of those really creates a geophysical hazard risk. It makes you, it places you in a really risky position. So let's talk about demographic factors. This one is interesting. So the first one is age distribution. So, around which age range you are, it might, make you more prone to the geophysical hazard risk, or it would make you less vulnerable. So I am not calling out names, I'm not calling out ages, I'm just calling out demographic groups. So elderly people and children, and perhaps mothers with young children and mothers with, their own mothers and their own fathers, are people that are in geophysical hazard risk. They are more vulnerable to risks like this because, I don't want to be mean, but older people, like elders, are slower. And I'm not joking when I say this, but, it really takes time for them to evacuate sometimes, and they're not really tech savvy as well, so they might not catch up with the news. They might not understand what's really happening. They don't know how to call for an emergency service, but I'm pretty sure most of them can. But, it's just a broad assumption that you could indicate. So, and these demographic groups may require specific needs during hazard events. So they may face greater challenges in accessing, like, resources and assistance, right? They might need, like, healthcare procedures. They might be more prone to an injury. So, but then there's, like, so all this stuff. And especially with mothers, right? They have to take care of their children, and that really, I don't want to be mean to kids, but, because I am one, but it really slows them down. They have to take care of them. They're not really aware of their situation. They're panicking, but the mothers have to keep on moving, and it really slows them down as well. So these kind of demographic groups really are vulnerable to these geophysical hazard risks. But do not take for my word. This is just a broad assumption that you can use for your essay. This is not what I think. This is just an assumption that you could use for an essay. Okay, so, let me look at more of my notes, see what I have written. Okay, well, I think I wrote about how Haiti, their median age is 23.5 years old, 23 years old, while Japan, it's like 46.5 years old. Yeah, that is quite a difference. That is like a 20-year difference. So, but then the situations, their economic situations are really different. So, yeah, demographic groups are significant, but economic factors really, weigh up the overall risk and vulnerability a society is to a geophysical hazard. And it's also safe to say that elder people's health, it's more fragile. It's more fragile. And but this is a good thing. They have a longer memory. So they have experience. So these elderlies might have experienced earthquakes before. They may know what to do. They may know, oh, okay, this is it. There's an earthquake happening. I know what to do. And I'm going to tell my kids that. I'm going to tell my grandchildren that. I'm going to tell my great-grandchildren that. So in that sense, that is great because they can transfer information down to generations. Yep. Okay, now let's move on to the last one. This video is getting a bit too long. Okay, so political factors. So here we're talking about governments, policy decisions, institutional capacity, policy implementation, and government structures. Oh, sorry, I accidentally moved on without moving the slides. This was just a comparison saying that, younger people may have they have more mobility, younger demographics. So yeah. Okay, so let's talk about demographic factors. Oh, political factors. This is not organized. Excuse me. Let's just go back to demographic factors real quick. So this population pyramid is also really good to know. So whether a country's in stage 1, stage 2, stage 3, stage 4, which is same as the age distribution, gender distribution, it will impact how a country is placed against a geophysical hazard. So lastly, let's talk about political factors, which again I said is government-related, policy-related, institutional capacity-related, all the political stuff that we all love. Okay, let's get started. Okay, so these things, as I mentioned before, have the power to shape vulnerability and resilience. So effective governance and transparency in decision-making really help reduce that risk against a geophysical hazard. But political instability, corruption, inadequate disaster management, and governance can undermine hazard preparedness, response, recovery efforts, and etc. And effectiveness of lines of communication, availability, and readiness of personnel is also really important. And some countries lack that. Some countries are corrupt. They exploit money and they don't use their government expenditures on social services and aid and just improving the country and rely on foreign aid. Okay, so now let's talk about political factors in Japan. So Japan dispatched about 100,000 troops to rescue and assist survivors of the earthquakes. And when I mean troops, I mean the self-defense force, because they're not allowed to have an army. They're rapidly mobilized the whole entire rescue process and procedure, and they all designated earthquakes in Japan, they designate earthquakes as special type of emergency, so giving preferential treatment such as extending validity of driver's licenses and postponing bankruptcy proceedings. And Japan has quite a broad international relations with many countries, and especially with the U.S. So during the earthquake, the U.S. actually helped Japan by deploying their U.S. Navy aircrafts, which, helped citizens evacuate their buildings and rescue them out of the tsunamis and crushed buildings and provide them with aid. And Japan also set up evacuation shelters and in schools. And the thing with Haiti is Haiti has a government problem of not managing well. And they have a lack of, they lack a population of educated engineers and architects and construction workers, as I said before. And this really, really, really impacts the vulnerability, the risk they have. Because this can also be part as a political factor, because the government regulates this employment job market. But even if they regulate it, there's still people that are like not certified, and they're working and they're building buildings that would literally crash down within minutes. And they don't really have building inspectors as well. In most HIC countries, when you build a house, especially in countries where earthquakes are a problem and geophysical hazards are a problem, they would inspect your house to see if it has the appropriate things, if it meets the building codes, and if it can, essentially withstand an earthquake, withstand not a volcanic eruption. But yeah, they don't have that. And, Haiti's government has high rates of corruption. And yeah, that really impacts the risk it's in. So yeah, that's about it for this video. I was yapping most of the time. I'm sorry. My notes are like 3 bullet points. So thank you for watching.